Welcome guys to today's class. In today's video, we will be discussing the topic circular or rotational motion. Yes. What is circular or rotational motion? It's important to say that circular or rotational motion simply means movement of a body around a circular path. Yes. When anybody is moving around a circular path, we say it is undergoing circular motion. What are some of the examples? One, movement of the earth round the world, round the sun. We call it rotation of the earth. Is an example. Movement of a compact disc in a DVD machine. Movement of a compact disc in a DVD machine is another example. Movement of a car round a what? Circular path. Yes, at the roundabout, you see a car move round that roundabout. Is also a circular what? Motion. Yes. Which other example do we have? Okay. Movement of a what? Blaze of what? Ceiling fan or what? Standing fan, whichever one. The movement of their blades is also circular or rotational motion. Now, it's important for us to note the following points about this circular or rotational motion. One, if a body, this is a circular path that the body is to what? Embark on. It's important to tell you that the velocity of a body undergoing circular motion is not constant. It varies. I take it again. The velocity of every body undergoing circular motion is not constant. Instead, it varies. And its velocity is always at tangent with that circle. Always at tangent. Tangent means it touches the outer part of that was circular part. Always at tangent with that circle. Always at tangent with that circle. Are you getting it? And so we have it this way. These are what we call tangential velocity because the velocity are not constant. It varies at one point to what? Another. Are you getting it? But the speed of that body is constant. Remember that velocity is equal to speed with direction. So speed is the magnitude of a velocity, and so speed is always constant, but the velocity of it varies or changes. What about the what? Acceleration of a body that undergoes circular motion. The acceleration of a body that undergoes circular motion is directed towards the center. Are you getting it? It's directed towards the center, and so the acceleration is not constant. It also varies. But the magnitude of the acceleration of a body undergoing circular or rotational motion is constant. Yes. Remember, magnitude is a scalar quantity. Magnitude. So, magnitude of a body undergoing magnitude of acceleration of a body undergoing circular motion is always what? Constant. But the acceleration of that body is not constant. Get that information. Acceleration is equal to magnitude of acceleration. Magnitude of what? Acceleration plus its direction. So when we are talking about magnitude of acceleration, it's like talking about velocity equals to speed plus its direction. And we said that the speed of a body undergoing circular motion is constant, but the velocity varies because of this direction we have. Then magnitude of acceleration of a body undergoing circular motion is always constant, but the acceleration itself varies because of the direction we have here. And also the acceleration of a body undergoing circular motion is directed towards the center. Yes, in other words, its centripetal force is also what? Directed towards the center. The force that helps for that body to be what? Moving in that circular path is always directed towards the center. Yes. Now, as you have noted these points, it's important for us to what? Derive important formulas we need for this what? Topic. Now, the first formula we want to look into is the formula that says you have a circle. As you have this circle, look at the center of the circle. Any line that is drawn from the center of the circle to this circumference, look at the circumference, we call it the radius. If you have it again, you call it the radius. Can see the displacement now. Here will be called the displacement from here to here. We call it the displacement. And here is the angle formed by the radius. Do you notice that as you are increasing this angle, that this s will also be increasing? If I increase it, the s will also increase. Do you notice that? And so we say that s is directly proportional to theta. S is directly proportional to theta. Are you getting it? And so, since S is directly proportional to theta, it means the higher the displacement, the higher the theta. Now, we also say again that sign of proportionality is the same thing with equals to K. So we have K theta equals to S. What is the constant we are talking about? Is radius. Radius is always constant in this circle. Are you getting it? And so we will be having S equals to R theta. Making your what? Theta subject to formula. Theta will be equals to what? S over R. That is noted. Then we also have again that theta you are seeing here. This theta you are seeing here is equals to what? 2 pi. 2 pi, that is circumference of the circle, 2 pi r all over radius. When you say theta equals to circumference of a circle all over what? R of a circle all over r, it will be giving you 2 pi r all over r. That will be giving you theta equal to 2 pi. So we will also have theta equal to what? 2 pi. Yes. Since theta is equal to 2 pi, what is also another formula for theta? Do you still remember what we call angular velocity? Angular velocity simply means W equals to rate of change of angle. Rate of change of angle. And therefore, we'll be having theta again to be equal to WT. So you have this, you have this. We will now bring it into what we have here. We'll be having WT equals to S over R. That is the first. Now, as I have gotten this T will come down, R will go up. That is from principles of cross multiplication. So we'll be having, therefore, WR is equals to S. Because R go up, T come down. We have displacement over time. Do you still remember that velocity is equal to displacement over time? If you still remember that, it means that WR is equal to V, because S over T, which is displacement over time, is V. Okay? So we will know this formula now, that V is equal to WR. Very important. Therefore, W equal to V over R. R equal to V over W. We have noted the first formula important for us for this class. Next thing we want to go into is, since we've been able to get our what? Our velocity, linear velocity. We call this linear velocity. We call this one angular velocity. We call this one radius. We have seen the relationship between linear velocity, angular velocity, and radius. Next thing we need to also check out is, what is the meaning of what? Angular acceleration is equal to rate of change of angular velocity. That means change in angular velocity all over time. that is rate of change of angular velocity, equals to W2 minus W1 all over what? T. Now, W2 is final angular velocity, W1 is initial angular velocity, and this is time. What is formula for final angular velocity? Okay, final linear velocity equals to what? Final angular velocity times r. Final linear velocity equal to W2r, because this is final angular velocity times radius. It will give you final linear velocity. Then initial linear velocity is equals to what? Initial angular velocity times what? Radius. So here I'll be having W2 equal V over R, and U equal to what? W1 equal to U over R. So I'll be having them to be alpha equals to what? V over R minus U over R divided by what? This time. Are you getting it? And so since it goes like this, this implies that LCM is R, V minus U, because this divide this one times it, this divide one times it, divided by what? T. Therefore, this will be equals to V minus U all over T times 1 over all over R times 1 over T all over R. Change division to what? Times. Invert. This is over 1. Invert it because you have changed division to times. 1 over T. So what we do here is that you take this R up and leave this T here. Therefore, alpha R will be equal to what? V minus U all over T. Remember that V minus U all over T. Remember that this is equal to V minus U all over T. Remember this from your linear motion formula. And so we will be saying alpha R is equal to A. Another important formula you should not forget. Yes. So whenever you are asked to find linear acceleration for a body undergoing circular motion, say angular acceleration times radius. So our next formula, linear acceleration equals to angular acceleration times radius. Angular acceleration equals to linear acceleration all over R. Very important to note them. Okay, we have noted this now. The next thing we want to note is about centripetal acceleration and what? And the centripetal force. Let's understand what we mean by that word, centripetal acceleration and centripetal force. When you see a body undergoing what? Circular motion. Look at this body undergoing circular motion. Yes. As this body is moving on this what? Orbit or circular orbit, there is possibility that this can fall out or fall in. But why is it not falling out or falling in? It is because there is a centripetal force and centrifugal force in action. There are centripetal force and centrifugal force in action here. The centripetal force is moving inward like this, and centrifugal force is moving outward like this. Both of them are equal. Remember I said the centripetal force that are what? Involved for a body to move in a circular motion, it is always directed towards the center. You see the direction now, towards the center. It's not moving out. Are you getting it? So this centripetal force is pushing this towards the center, while this is pushing it out. Yes. So these two forces must be equal. Otherwise, this body will not what? Be on this orbit revolving. Are you getting it? Now, it's important for us to know that this centripetal force, which is equal to centrifugal force, is equal to mv squared over r. Yes. That is from what? Mass times acceleration. Are you getting it? And we know that our v is equal to wr here. So it means that acceleration or centripetal acceleration, which is also directed towards the center, is equal to what? V squared over R. And our V is equal to WR here. You say WR all what? Squared all over R equals to what? W squared R squared all over R equals to W squared R. Are you getting it? Then also remember that R is equal to V over W. So we have gotten this formula for centripetal acceleration, gotten this formula for centripetal acceleration. The next formula for centripetal acceleration is W square bracket. What is your R? V over W. V over W. And that will be giving you, this will cancel one of these to be W. WV. So for centripetal acceleration, this one is linear acceleration. Linear acceleration. This one is centripetal acceleration. Are you getting it? So they are different. So what you do is that centripetal acceleration is equal to what? V squared over R. Okay? Centripetal acceleration can also be equal to W squared R. Centripetal acceleration can also be equal to what? WV. It is because a body moving in a circular what? Motion or in a circular pattern. Are you getting it? Is related to a body that is undergoing simple harmonic motion, to and fro. That is why we say AC is equal to W square R. Are you getting it? Because when we treated simple harmonic motion, we said that the acceleration of it is W square X, where X is now this R, because of in a circular orbit, radius will be that what? X. Are you getting it? And so we have noted the formula for centripetal acceleration. Now for centripetal force, since force is M times A, centripetal force will be equal to what? M times AC, which is V squared over R. Centripetal force equals to MW squared what? R. Centripetal force equals to MWV. That is mass times this acceleration, mass times this centripetal acceleration, mass times this centripetal what? Acceleration. This is V. Okay? This is V, not R. Mass times angular velocity times linear velocity. So these formulas we have just derived are very, very what? Important for you to know them if you are answering question on what? Circular or rotational motion. Okay, we want to discuss horizontal circular motion of a body. That is, when a body undergoes horizontal circular motion, what happens in that condition? Now, what do we mean by a body undergoing horizontal circular motion? If you want to understand it well, picture your mind to how ceiling fan rotates. It rotates like the horizontally. When a body is moving horizontally like this, we say it is horizontal what? Circular motion. So a lot of things happen in a body that undergo horizontal circular motion, so to speak. And that is what we want to sort out now. Now, look at this body now. Look at that ceiling fan rotating horizontally. Here, the force that is on that blade of that ceiling fan, helping it to rotate horizontally, the force that is on that blade is directed to what? Towards the center. I get it. You know, here is radius, but there is a force acting on it. Then the weight of the body acts downward normally now. Weight of the body acts what? Downward. Then here there is a tension. Tension means a force on that what? String or spring. There is a tension. Then that means if I'm using this to rotate this body now, there is a force on this rope that is helping it to what? Rotate round without cutting. We call it tension. Are you getting it? Then we have talked about F, we have talked about this. Now in terms of their length, here is their slant length, and here is the vertical what? Height, and here is radius. Slant length, vertical height, and radius. Are you getting it? So this is where the body is what? Clamp. This is where it is clamp. Okay. Then as you are seeing it like this now, as you are seeing it like, they want to do some important derivation. Yes. If they ask you to find the radius of a body undergoing horizontal circular motion, the radius of it is equal to, here is your theta. We'll apply the principle of SOHCAHTOA to sort it out. This is opposite to this angle. Are you getting it? And this is angle 90 degree. This is your hypotenuse and this is your adjacent. Are you getting it? So because that this is what? Opposite to the angle, we say, if I'm using so like this, my opposite is what? R. My hypotenuse is what? L. Okay. Using my so, I will say sine theta is equals to, my opposite is R and my hypotenuse is L, because that is the side facing angle 90 degree. So you use the trig ratio that will connect R, or that will take care of this R we are talking about, by saying SOHCAHTOA. Sine theta equals to, O is what? Opposite, which is R. Or hypotenuse is L. Therefore, to get your radius of a body undergoing horizontal circular motion, we say equals to the length, the slant height, that is the length, times what? Sine theta. The unit is in meter. SI unit can be in meter, yes, but other units can be in centimeter, millimeter, and others. Then what if they are asking you this vertical height? To get the vertical height, okay, check what connects this vertical height to the diagram we have. Car, let's check car. Car said his name is cos theta equals to, adjacent is what? The h. All over the hypotenuse is the L. Therefore, the vertical height h, vertical height what? H is equal to L cos theta. The unit, SI unit is in meter, other units can be in centimeter and all have you. So in terms of their heights or the length or whatsoever, like radius, vertical height, look at the formula you have to use to sort it out. Now let's talk about forces that are on this what? On this body undergoing circular motion. If I rotate this like this, if I rotate it such that, look at it, so that it will be easier for me to sort. This is it, I rotated it, and if I rotate it, here is my T, here is my W, then what else? Here is my what? F. These are what? Forces, so to speak. Force in terms of tension, force that is the centripetal force, the force that is directed towards the center, and the weight of that what? Body, which is this one. The weight of a body is always directed close to the ground or to downwards. Weight of a body is always directed downwards. Okay. Now as you have it like this, note that there is what we call resolution of vectors. Yes. Now this tension you are seeing here is in between the vertical and the what? Horizontal. So I will give the shear for the vertical and give the shear for horizontal. Remember that this vertical you are seeing is opposite to this force. Are you getting it? And so to resolve it so that you give the shear for T to vertical and the shear for horizontal, all you need to do is that you say to get this horizontal shear, I will say T cos theta. I use cos to get the horizontal own. You want to what? Resolve it. Yes. T cos theta. Also, you must also use this theta that you make with horizontal now to also get the one of vertical. The one of vertical will now be T sine theta. The only difference between the one of horizontal and the one of vertical to share this is cos and sine, but they must make use of the angle is mixed with horizontal. Very important. Now, this is my T sine theta, and this is my what? T cos theta. Now, this is equivalent to this, and so this is also equivalent to weight because they are in the same place. So this you say is equal to what? Force, and this is equal to what? Weight. You are done. Okay, from this our resolution, we will bring it down. Weight of a body is equal to mass times acceleration due to gravity. Force of a body undergoing circular motion, in this case horizontal circular motion, is called centripetal force, which I said is always directed towards the what? Are you getting it? Is always directed towards this center. And so that centripetal force is equal to mv squared all over r. So we'll be having T cos theta equals to W and equals to mg, and also T sine theta equals to what? Fc equals to mv squared all over r. Now dividing this equation 2 divided by equation 1, we have T sine theta all over T cos theta. That is to simplify it further, equals to, if I keep this and use this to divide it, I will also keep this and use this to divide, mv squared all over what? R divided by what? Mg. I kept this divided by this. I also kept this divided by this. Here, this will cancel this. This will cancel this, giving you what we call tan theta. Because once T divides T, sin theta over cos theta is tan theta. Are you getting it? Equals to V squared all over what? Rg. V squared all over Rg. Therefore, what is my V square? My V square is equal to Rg tan theta. Therefore, velocity of a body undergoing horizontal circular motion is equal to square root of what? Rg tan theta. So you should not forget that V is equal to Rg tan theta, all inside square root. Very important. So velocity of a body undergoing horizontal circular motion or undergoing circular motion is equal to V equals to square root of Rg tan theta. Don't forget that. Okay, we move further to find out, since we have gotten the velocity, let's get their angular velocity. The angular velocity of a body that undergoes circular what? Motion. Now, to get the angular velocity, remember that we noted that V is equal to WR. Therefore, W equals to V over R. Therefore, W, what is my V? Square root of Rg tan theta all over R. That is my what? Angular velocity. Angular velocity equals to square root of Rg tan theta all over R. Simple. Then another formula we need to also get is the frequency and the period of a body that undergo what? Horizontal circular motion, or that undergoes circular motion, so to speak. Now, remember that theta is equal to WT, where the T is the period. And from what I said before now, that theta is equal to circumference of a circle, all over radius is equal to 2 pi r, which is circumference of a circle over radius, equal to 2 pi. So what I will be having here now is that, bringing it here, I will say theta is equal to what? 2 pi is equal to WT. Therefore, T, which is the period, this T now is the period, will be equal to 2 pi over W. And what is your W? We have it on the board here. Equals to 2 pi all over square root of RG tan theta all over R. So simplifying this, we have that theta period will be equal to what? 2 pi times this. Period equals to 2 pi times R all over what? RG tan theta equals to 2 pi R all over square root of RG tan theta. So we have gotten our period to be equal to what? 2 pi R. 2 pi R all over square root of RG tan theta. Yes. Then, since we have gotten formula for period to be 2 pi R all over square root of RG tan theta, what about the frequency of it? Frequency will be equal to 1 over period is equal to what? Square root of RG tan theta all over 2 pi R. That is inverse of this. So F is equal to square root of RG tan theta all over 2 pi R. Now, do you believe that this T equals to 2 pi R we have gotten all over square root of RG tan theta, that is this period, is equals to 2 pi root L cos theta all over what? G, or 2 pi root H all over what? G. Do you believe that? This thing you are seeing that is equals to this. Okay, let me explain. Remember that your R is L sin theta. We had that R is equals to L sin theta here, right? And so bringing it inside here, we'll be having T equals to 2 pi L sin theta, okay, divided by square root of what? L sin theta, which is this R, then G bracket sin theta over cos theta, which is equal to tan theta. Yes. Now, as I've gotten this one is in square root. This one must also be in square root, otherwise you can't sort it out. So I watch what I will do. T equals to 2 pi. I bring out 2 pi and square here. Square root of L square sin square theta is equal to L sin theta. I didn't change anything. All over square root of what? L sin theta times sin theta is sin square theta. L sin square theta G all over what? Cos theta. All over cos theta. Now, as you are seeing this now, all of them are inside square root. So what I will do here is that I will now say T is equal to 2 pi square root of what? L squared sin square theta divided by what? L sin square theta. Let's write it well. L squared sin square theta divided by L sin square theta g all over cos theta. So they are inside square root, all of them. If you change division to times, you invert this to give you cos theta all over L sine square theta bracket g. So this will cancel what we have here. L will cancel what we have here, leaving you one L. So t is equal to 2 pi square root. Therefore, t is equal to 2 pi square root of L remains here. L what? Times cos theta all over g. So we say that period is this, and that same period is equal to 2 pi this equals to what? 2 pi root h over g. Now this h you are seeing can come in many ways. When you are talking about spring, are you getting it? You know, spring can also embark on what? Simple harmonic motion. So this formula can also be used in simple harmonic motion too. Since we know that there are bodies that embark on what? Horizontal circular motion, and at the same time embark on simple harmonic motion, like simple pendulum that is moving like this. Are you getting it? So if simple pendulum also embark on circular motion per se, it means that this formula can be used on it, and also this formula can be used on simple harmonic motion too, but you need to check it well. Take for instance spring. Now spring, when you vibrate spring, it will be doing up down up down. Are you getting it? In that case, h you are seeing here can be called the length of the spring. The way that the h of this is the height, the height of the spring here will now be equal to 2 pi root L over g, in terms of if you are talking about spring, for instance. Then if you are talking about extension, if you are dealing with extension, you have something, you stretch it, it has extended. It means that this h you are seeing will be equal to what? Extension over g. Are you getting it? Then in terms of mass, I'm just showing you all the different formula for what? Periods. Are you getting? Whichever one, depending on the parameters that are given, we will see practice question we will do so that you learn more. Now, what if we are talking about floating what? Cylinder that is floating. What is the period? Period is equal to 2 pi root what? M over A P G. Yes, that is mass all over what? Cross-sectional area, density, and what? Acceleration due to gravity. What about spring? This can serve for spring, this can serve for spring. But in terms of mass, we also have period equals to 2 pi root what? Mass all over the spring constant. So these are different formulas for what? Periods. Very important for you to know. Whichever one that they gave you the parameters, once you finish getting it, you invert it, your answer, you get your what? Frequency. Once you invert your answer, you get your frequency. Let's go to practice questions that will help us to appreciate this topic. Okay. Question number 1. A flywheel with mass 10 kg makes 300 revolutions per minute. Find angular speed W of any point on the wheel. Now remember that the unit of angular speed is radian per second, not revolution per minute. No. So all we need to do is to convert 300 revolution per minute to what? Radian per second. Once we convert it, we have gotten the angular speed. Okay, that means 300 bracket revolution. Revolution means 1 rev or over 1 minute to radian per second. To radian per second, we'll be having what? Is equals to 300 bracket. 1 revolution is equals to what? Note that 1 revolution equals to 2 pi radian. 2 pi radian. Are you getting it? So I will be writing 2 pi radian all over 1 minute is equivalent to 60 seconds. 60 seconds. So I will be having this divide this. We have what? 5. Because 5 times 60 is 300. 5 times this will give you 10 pi radian per second. So your angular speed W is equal to 10 pi radian per second. Yes. Then linear speed of a point 2 meters from the center. Okay, linear speed V is equal to omega R. That is angular speed times R. And that means angular speed is what? 10 pi times radius is 2 meter. 2 meter. That will be giving you 20 pi meter per second. 20 pi meter per second. Then centripetal force. Centripetal force, this is equal to what? mv squared all over r. What is your m? 10. What is your v? Your v is 20 pi or what? Squared all over. What is your r? R is 2. This will cancel this to give you 5, right? That means 5 times 400 pi squared, right? Newton. So that will be giving you 5 times 400 is what? 2000 pi squared in Newton. So we'll go to question number 2. So a 5 kg ball is fastened to the end of a spring. A force of 20 Newton is sufficient to pull the ball 6 cm to one side. Find the force constant and the period of the vibration. The mass of the ball is what? 5 kg, right? And it's fastened to the end of a spring. You have a spring and you fasten the ball there. Now, the force of 20 Newton is sufficient to pull the ball 6 cm to one side. Find the force constant. Okay, we noted that F is equal to Ke. Therefore, Ke will be equal to F over E from springs. Yes, or from string. The force is equal to 20 all over the extension is this 6 cm we are talking about, which is equivalent to 0.06 meter. 0.06 in meter. Okay, so your force constant will be equal to 20 divided by 0.06. That will be equal to what? 20 divided by 0.06. That will be equal to 333.3 Newton per meter. That is the force constant. Then the period of vibration. Period is equal to 2 pi root m over k, as I said before now. Yes. So is equal to 2 pi root. Your m is what? 5. All over what? 333.3. Okay. So we say 2 shift pi times root bracket 5 divided by 333.3. That will be giving us what? 0.77 seconds. Yes. We said 2 shift pi times root bracket 5 divided by 333.3. That is that. Okay, we'll go to what? Question number 3. String of a conical pendulum of length 80 cm. We say the length is equal to what? 80 cm. Yes, that length is 80 cm, which is equal to 0.8 meter. And makes an angle of 60 degree with the vertical. Theta is equal to 60 degree. So look at how the sketch goes. Look at the fan and look at that what the length they gave us, and look at the movement going to be what? Circular. That is horizontal circular. So this is the height, and look at how the length make an angle of what? Theta here. Are you getting it? So since this is that, we say that for us to get the radius of the circle r, we derive it to be L sine theta is equals to L sine theta 0.8 sine 60 degree. What will it give us? 0.8 sine 60. That will be giving you 0.693 meters. Then vertical height of the string h, that is the vertical height, we say it is L cos theta, which is what? 0.8 cos what? 60. 0.8 cos 60. That will be giving 0.4 meter. Then the time taken for one complete oscillation, time taken, that is the period, is equal to 2 pi root h over g. As I said, yes, not r over g, but the one of h. Yes, we got it from saying L cos theta over g. So 2 pi root 0.4 all over what? Where your g is approximately to be 10. Yes, so 2 shift pi times root bracket 0.04 equals to 1.26 what? Seconds. 1.26 seconds. Okay? Yes. Then the frequency will be equals to 1 over t equals to 1 over 1.26. What will it give us? 1 divided by 1.26 was 0.79 per second. 0.794 per second, or 0.794 hertz. So we'll go to question number 4. An object of mass 10 kg is wheeled around a horizontal circle of radius 4 meters. I will say mass is equal to 10 kg. Radius is equal to 4 meters. By a revolving string inclined to the vertical. The angle at which it's inclined to the vertical is not given up. Calculate the tension in the string if uniform speed is 7 meters per second. Okay, V equals to 7 meters per second. Now, since the theta is not given, the angle is inclined to the vertical is not given. You say theta is equal to tan inverse of V square all over RG. Since we noted that V square is equal to RG tan theta. That is from this formula. From this formula, I made theta to be equal to tan inverse of V square over RG. Yes, that is how to make theta subject of formula. Then as I have it here, I'll be saying tan inverse bracket 7 square all over 4 times 10. Yes, taking G to be equal to 10 meter per second. Yeah, the G is constant. So I will be having shift tan bracket 49 divided by what? 40. That will be giving me 50.8 degree. 49 divided by 40 equals to what? 50.8 degrees. Then the tension, to get the tension, do you remember that T cos theta is equal to W is equal to mg from our derivation? Yes. Therefore, T cos theta is equal to mg. Okay? T will be equal to mg all over cos theta equals to m is what? 10. G is 10 all over cos 50.8. Yes. 100 divided by cos 50.8. That will be giving you 158.2 Newton to be your tension. Yes. So that is how to solve this problem we have on the board. If you find this video helpful, don't forget to follow us, click subscribe, like the video, share to your friends, and see you next time.